Good day to everyone who's watching. Our lesson today, we are going to talk about Surds. Now, before we proceed with the Surds, I would like you to share this video to your friends in your school or in other schools so that we can have more views of this video. Going to the Surds, we are saying that there are some numbers that have perfect square roots. For example, the root of 4 there has a perfect square root. The root of 9 has a perfect square root as a 3. Then there are some numbers which cannot be expressed as fractions. So those ones, their square roots give us the small places when we place them on the calculators. So I can say they don't have perfect square roots, yes, or their square roots are not whole numbers, yes. A whole number can be expressed as a fraction. That is why I'm saying those numbers cannot be expressed as fractions. Then the other numbers, these ones here, we call them rational numbers, and these ones here, we normally call them irrational numbers. So the irrational numbers are the ones that we call the surds. Then we go to the rules of surds, or the rules that are going to govern us while we are simplifying numbers in examples. So the first one there, we are having, if I have the square root of a times b, the a and the b is under root, I can simplify by taking the root of a times the root of b. So either way, we are going to use this in the upcoming parts of the lesson. An example there, if I have root of 4 times 3, this is equal to the individual root of 4 times the individual root of a 3. When I go to the second one, I'm having a number which is not under a square root times the number under a square root. So if I want to take this one back to be having square root, first of all I need to square it, then I put it under the square root. Why? Because when I try to use this, you will see that the root will be cancelling out with 2. An example is 5 times root of 7. This one I get root of 5 squared times 7. Those two are now inside the bracket of the square root. When I go to the third one, root of a times root of b, if it is just a number there, this one without a root and another one with a root, so we just leave it the way it is, a times the root of b. So we shall be, when we have this, we shall be just writing it like that. An example is 8 times root of 2 is the same as 8 root 2. When we go to the fourth one, this one is either addition or subtraction. If I have a root of b plus or minus c root b, that this one here, we shall create brackets, then we try to add the constants which are outside the roots, or subtract the constants which are outside the roots. In this case, root of b and root of b are common. That is why we factor it out. Then we add the constants or subtract the constants which are on the root. An example, 11 root 5 plus or minus 3 root 5 is equal to, into, we shall be adding the 11 plus or minus 3 root of what? Root of 5. Now that plus or minus 3, let it not confuse you, because we shall either be having an addition or we shall be either having a subtraction. Now the root of 5 and root of 5 there, it is like I'm having m. So 11m plus or minus 3m, we shall be adding constants there. That is why we normally add these constants, then we multiply by the root there. When we go to the fifth one, this one is coming from the first one, but now the values inside the square root are the same. When we go back to the first one, we say that if we have that, this is what we shall be having. So now here we are having the a, and now taking back that direction, now we shall be having the a times the a, then that's where we have the s squared here under the square root, then the root will cancel with the square. In index form we saw that to have just a. An example is root of 2 times root of 2, and this one is going to be equal to root of 2 squared. The square cancels with the root, and we finally have the answer as a 2. So we go to the examples. Number 1, simplify the following, and our part A is going to be the root of 8. Now to simplify these expressions of surds, we are going to find a way of identifying a square number within that number under the square root. When you look at 8, there is a 4 which is a square number there, times the 2 to give us 8. So I'm going to first substitute the 8 as a 4 times a 2, which is that. Then I use the first law to write the individual roots of everything under the square root there. So that is root of 4 times root of 2. So I know the root of 4 as a 2. So I'll be having a 2 times the root of 2, which we said that it will just be 2 root 2. Then when I go to part B, I'm having my root of 50. Now when you look at 50 alone, the square number which is embedded there in the 50 is a 25. So the 25 times a 2 gives us a what? A 50. Then I substitute it there. So I write the individual product of those square roots, that is root of 25 times root of 2. Then finally I'm going to get the square root of the 25, which is 5, then times the root 2 to have the answer as 5 root 2. When I go to part C, also the 12, I can say that a 4 is embedded there, and the 4 is a square number. So the 4 times the 3 gives me the 12. Then I write the individual product of the square roots, that is root 4 times root 3. Then the root of 4 is a 2 times the root 3 to have 2 root 3. When I go to part D, root of 20 plus root of 5. Now, here we have two expressions there. When you look at the 5, there is no square number embedded there. So we concentrate so much on 20. So the 20, there is a 4 times the 5. and we first simplify that. So that gives us root of 4 times 5, then plus the root of 5. Then on the next step, we just simplify it faster. Now we are going to be doing things faster because we saw that where it comes from the first part, the second part, and the third one. So on the fourth one, when we see the square number on the next step, we shall just take its square root right away. So we are having 2 root 5 plus root of 5. Now here we have like terms, that is the root of 5 and root of 5 there, and this root 5 here has a value here, the 1, although we don't write it. So in the next step, we are going to add a 2 to a 1, then we put our brackets into the root of 5, which is that. Then when we add 2 plus 1, we have 3 root of 5. When we go to part E, we have 7 root of 24 plus 3 root of 54, then minus 4 root of 216. So like I said, those numbers under the square roots, we are going to find ways of identifying the square numbers which are inside there. When you look at 216, there is a 36 which is embedded there, and the 36, when you multiply it by 6, that's the 216 that you get. The 54, there is also a square number embedded there. The 24, there is also a square number embedded there. So the 24 is the same as 2 times 6. The 54 is the same as 9 times 6. And the 216, like I said, is the same as 36 times 6. So now we are going to get the square root of that, then the square root of that, then the square root of that. But the 6 will be still under a square what? A square root. So the 7 is going to multiply the square root of 4. And we are having something like that, a 2 times the 7, then a 3 times a 3, then a 4 times a 6. Now, when we multiply here, we have 14. When we multiply there, we have a 9. When we multiply there, we have a 24. And then since the values under the square root, they are the same, we are going to add the 14 to 9, then minus the 20 what? The 24. We are having something like that. Then when we simplify, we are having negative 1 root of 6, which we can rewrite simply as the negative root of 6. Number 2, evaluate the following. The first one is root of 3 times root of 27. Here we are going to first write or express the expression as a single surd, or in a form which is just root of a number under a square root. That part A. Our first step is to make the 3 to multiply the 27, since both of them are under a square root, which is that. Then the next step, we are going to see the result. When we multiply the 3 times the 27, what do we get? So the root of 81 there, the 81 is the same as 9 squared, and 9 squared under a square root, we shall be having just a 9. there. When we go to part B, root of 18 times root of 8. So as the first one, we're going to do the same thing here. The 18 is going to multiply the 8, and both of them are still under the square root. Then when you multiply the 2, we are having 144. Then the 124 is 12 squared. Then square root of 12 squared is going to give us a 12. Then we go to number 3, expand and simplify the following. So even in Surds, we can have two brackets multiplying each other, and the expansion here we are doing, we shall later see that it's going to be useful in the next parts. So like in O level, we used to expand. If we have two brackets, the first step is to make the 3 to multiply the whole of that bracket, then the minus root of 2 to multiply the whole of that bracket. So this is what we have there. Then when you open the bracket, the 3 has to multiply the 4, the 3 has to multiply the root of 2 there. The negative root 2 has to multiply the 4, the negative root 2 has to multiply the positive root 2 there. So when we open the brackets, that is going to be a 12 times 3 root 2. Then when you open the second bracket, we shall be having a 4. I'm beginning with a 4, not to confuse myself, because when you write root of 2 times 4, someone may think that the 2 is multiplying the 4. That is why I'm first writing the 4, then times the root of 2. Then lastly, when you multiply root 2 times the root of 2, first of all, the sign there is negative. That is why the sign is negative. Root 2 times root 2, go back to number 1, and you see how we came up with the root of 4, or root of 2 squared. So the next part, we are going to simplify this here, and since these ones are like terms, we are going to also add them. So the 3 plus the minus 4, then the 12 is there, then the root of 4 is the 2. Then the next step, we are going to add the 12 to the negative 2. So when you add the 12 to the negative 2, we are having positive 10. Then even here we are having a negative 1 root of 2, to have the answer as 10 minus root of 2. When we go to part B, expand, just like in part A, the 1 is going to multiply the whole of that bracket. The 3 root of 7 is going to multiply the whole of that bracket. Then when we open the bracket, any number times 1 is that number. Then when we come here, 3 root of 7, it's only 3 which is going to multiply with the 3, because both of them are not under a square root, then times the root of 7. Then when we multiply this times that one there, the 2 will multiply the 3, and the root of 7 will multiply with the root of 7. So we are having something like that. Then on the next step, we are going to add like terms, this to that, the 2 plus 9 into root of 7, then the 6 times the 7, because square root of 49 is 7, which is that. Then when we add this, we have 11, then 6 times 7 is the 42. Then on the next step, we are going to see the answer when we add 42 to a 3. So that one gives us 45 plus 11 root of 7. So this one we cannot add, even that one we cannot add them because they are not like terms. Then we go to conjugate surds. What is a conjugate of a surd? So two surds are said to be conjugate to each other if their product is a rational number. Remember, we said a rational number is a number that can be expressed in index form or a number that can be expressed in fractional form. So when we multiply two conjugate surds, we shall be having the result of that product as a rational number. For example, we are having root of 2 times root of 2 is equal to root of 2 squared, finally to have a 2. So the conjugate of root of 2 implies that it is a 2, because when we multiply the 2, we are having a rational number in the end. The conjugate of 3 minus root of 7 is 3 plus root of 7. So here we shall be just changing the sign of one expression to get its conjugate. So let us try to multiply the two and see if we are going to have a rational number. So when we multiply there, the first step is to open the brackets. The 3 multiplies the whole of that bracket. Then the negative 7 is going to multiply the whole of that bracket, which is this here. When we further open the brackets, the 3 times the 3 is a 9 plus 3 root 7, then minus 3 root of 7, then minus root of 7 squared. So when I simplify this, I'm going to be having a minus 7, then I add it to 9. Then you can see that this and that are the same, but the signs are different, so they become a 0. To have 9 minus 7 to give us the answer as a 2, and the 2 is a rational number. Lastly, we can say that the conjugate of root of 11 plus 4 is root of 11 minus a 4. I've said you come to the expression and you just change the sign there to get its conjugate. Rationalizing the denominator. So in rationalizing the denominator, we are going to see that you must be knowing how to get the conjugate of a surd. To rationalize the denominator, we multiply the denominator and the numerator by the conjugate surd of the denominator. So that is the rule that we're going to be following in all the examples that we're going to do under the rationalization. Then we go straight to the examples. Rationalize the denominators of the following, and part A, we are having a 2 root of 3. So the rationalizing the denominator, we are trying to eliminate a surd from the denominator. That is why we get the conjugate and we multiply it both in the numerator and the denominator. So numerator denominator is like we are creating a neutral one, so there's nothing we change in the expression. So when we get our conjugate of root 3, we multiply it there in the denominator and then there in the numerator. This one in the denominator, we use the laws that the 3 is going to multiply the 3 and still under a root to have root of 3 squared, and that one is going to be a 3. So we have that. Then lastly we have 2 root 3 divided by a 3. This is the same as that, but the way we are just writing them, in many cases we are going to be writing it like this. Let it not confuse you. Both are the same. So our part B, we are told to rationalize the denominator. So the conjugate surd of that denominator there, you can first think of it. Then after thinking of it, let me hope you have written it somewhere. We are going to get it and multiply it both in the numerator and the denominator. So which is that? Then the denominator there, we are going to try to simplify it, because in the numerator 1 times anything is that anything. So in the numerator we shall be having root 5 plus 3. In the denominator we are going to go back to the expansion and we try to expand step by step. So when we expand root of 5 into the root of 5 plus 3, then minus 3 into root of 5 plus a 3 there. So we open even here, that's going to be 5, and then the other one's going to be 3 root 5. Then when we come here, it's going to be minus 3 root 5. Then this times that is going to be the negative 9. So the 5 times the 5, we can, okay, just write it as root of 25, but on the next step we're going to call it 5. These two, you can see that they are the same, so they are going to cancel out. Then we shall be having 5 minus 9 in the denominator. I'm not talking about the numerator because we said that it is going to remain the way it is all from the first step there. You can see it has been the same. So when we subtract in the denominator, we are having a negative 4. Then root of 5 plus 3 divided by the negative 4. Then when we distribute this negative there and there, we have something like this. That is the minus 1 all over a 4 times the root of 5, then minus 3 all over a 4. So I said we shall be writing it like this. Let me hope you have not forgotten. Or someone can factorize out the negative 1 all over 4. Then you write the brackets there, root of 5 plus a 3. So when we go to part C, we are still rationalizing the denominator. 3 minus root of 5 divided by 1 plus 3 times the root of 5. So we said we are going to get the conjugate of the denominator, then we multiply it by the numerator and denominator, which is that. So in the numerator, we are going to open the brackets, the 3 will multiply that, and the minus root of 5 will multiply the whole of that bracket also. Now when you look at the denominator there, we are seeing that we are having a factorization of difference of two squares. Remember in O level we had something like that. That's the factorization of a difference of two squares, and the difference of two squares is this one here. So when you look at the 1, we are going to take it as the A. The B, we are going to take it as the whole of 3 times the root of 5. So even here in this bracket, you can see it is the A minus the B. Then on the next step, we are going to be writing it as A squared minus B squared. So in the denominator we are having the 1 squared minus the 3 times root of 5. So still in the denominator we are seeing that this square is going to square the 3 and also square the root of 5 as we saw in index form. Now the square which is going to square the root of 5, it will just cancel out to have the 5 times the square of 3. When we go to the numerator, we looked at how to expand. So we are going to expand further, the 3 multiplying that and that, the negative root 5 to multiply that and that one there. So we are having the change of sign. The negative root of 5 is multiplying the negative 3 root 5 to have a positive sign there. So we simplify this on the next step. When you look at root 5 and 9 root 5, they are having negative signs there. So we are going to subtract them, or we are going to add them. Then in the denominator, I talked about the 5 multiplying the square of 3. Square of 3 is a 9. Then on the next step, we are going to get this answer here. There we are having the 3 plus the 15. Here when you simplify this, the 3 times the 5, we get a 15. Then this one here and that one there, we are having 9 minus 1. Then in the denominator, we are having 1 minus the 45. So when you add 3 to 15, we get the 18. Then the minus 9 minus 1, we get the minus 10 root of 5. Then in the denominator, we have a minus 45 there. Then on the next step, we are going to simplify. We see that in the numerator, there is a factor there and a factor there of 2. So when I pull out the 2, I'll be left with a 9 minus the 5 root of 5. Now the 2 here is going to reduce the minus 44 in the denominator to have a minus 9 plus positive 5 root of 5. So the negative here came in the numerator and it made the 9 to be a negative, and it made this negative here to become a positive. So we can rewrite the answer as 9 all over the 22 plus 5 all over the 22 root of 5 there. When we go to number 2, express that in the form a plus b root of c. When you look at this form where they are telling us to express our expression, you can see that we don't have a denominator having a surd. So what we are going to do is to eliminate this denominator by rationalizing it. So rationalizing the denominator, we get its conjugate, multiply in the numerator and multiply in the denominator, like that. Then we open brackets. Then in the denominator, we stick to difference of 2 squares. You identify your a and the b, then you square them. So the 4 times the 3, on the next step we are going to see that it is 12, and then the 9 times 2, we are going to see that it is an 18. So now we are going to add both in the numerator and the denominator the like terms. So when we add them, there we are having a 30. keeping this. Then in the denominator we are having a negative 6. There is also a factor of 6 in the numerator. We factorize it out, like here on the next step, to have the 5 plus 2 root 6 there. Then the 6 here is going to cancel out with the negative 6 there, and then we shall have our negative outside the bracket. When we open the bracket, we shall be having everything there as a minus, and then we can say that we have expressed into the required form, which is a plus b root of c, where my a is the negative 5, my b is negative 2, and lastly my c is the 6. Here I'm just trying to compare this to that, this to that, then this one under the root to that one under the root. Number 3, simplify 1 divided by 1 minus root of 3 minus 1 divided by 1 plus root of 3. So here we are subtracting two expressions having surds in the denominator. So we need to determine the LCM, and the LCM is going to be the multiplication of, again, these two denominators. So when I multiply here by the LCM, even there by the LCM, this is what I have. So you can see that this is going to cancel out with that, and also this is going to cancel out with that. Then the whole thing here is being divided by the LCM. So when we come to this, you can see that we shall be left with this bracket times a 1 to have the 1 plus root of 3, then the 1 times that bracket there to have the 1 minus the root of 3. Now we are going to open the bracket. It's like here we have a negative 1. It's going to make the 1 there negative since it is positive. Then the minus there is going to be a positive now. Then in the denominator, we express that one as a difference of two squares. So the 1 squared minus root of 3 squared in the denominator. Then we saw that the square is going to cancel with the root. So the next step in the denominator, we shall be having 1 minus 3. Then here we can see that this and that are the same but different magnitudes, so they will cancel out. Then the root of 3 here has a 1, and the root of 3 there has a 1. We shall need to add those ones there. So when we add them, we shall be having 2 root 3. Then in the downer part, I talked about it, we shall be having 1 minus a 3. And then when you subtract, we shall be having 2 root 3 divided by, and when you divide the positive 2 by the negative 2, we shall be having a negative root of 3. Then lastly, we are having our exercise there. Please try it out and endeavor to share the link. Try to subscribe, and we grow our channel.